Okay, so when you're drawing a displacement time graph, it is displacement over on top here, time in the horizontal. Displacement, time. So we are using meters, that is why we have got 18,000 and here 900. Now let us go to velocity. When we are calculating velocity, we say x divided by time, it gives us this. Let us go now to velocity time graph. Velocity time graph. So the graph of velocity time graph, when we draw it like this, what does it mean? Velocity was uniformly changing, not constant. The velocity was not constant, it was changing uniformly.
Yes.
As the time was increasing, velocity was also not doing what? Increasing.
Yes.
So, when I want you to see this clearly, when I want to calculate displacement, x, it is the area under the graph, this area. This is x. So what do you do? We say x is equal to half v times time. So we say 20 times 900 divided by 2. What's the answer?
$9,000.
Now, I have done this deliberately. Does it match with this?
Say again?
Does this answer match with this answer? With the displacement? So, it means that according to this one here, the velocity is considered constant, not uniformly increasing. So, because we are coming from this scenario, your velocity was what? Straight line.
Okay.
Then, it is the area under the graph.
Okay.
Can you see? Based on what we have here, it means velocity was a full line like this. But is this the truth? The point was saying it started from rest. But this scenario is only for acceleration. Are we together? This is only for acceleration. So, this velocity, we will treat it as the area under the graph. So, the 2 here will not be there. So that we have got 18. If this scenario, if we didn't have this acceleration, let's say we remove the weight rest. This is is the story we have. Acceleration if it took 15 minutes to move from A to D. What is our acceleration in this regard without the weight rest involved? When the velocity is constant, what is the acceleration? It means there is no acceleration. Acceleration will be what?
0.
0. Because final velocity and the initial velocity, they are what? They are both same size. It means when you are driving along that curve, if you are running at 20 kilometers per hour, you were running at 20 kilometers per hour throughout until you reached the D. You started from A until D. Same speed, no change.
Yeah.
It means acceleration is 0. Therefore, velocity is the same, but displacement is 18. Distance is the one that was changing and time. The rest were constant.
Okay. Yes.
Yes, I understand, sir.
You understand me? That is why I deliberately had to put rest here so that we see how acceleration can work. But if there is no rest here, we follow the graph that was given. Acceleration calculated from this graph, it will be 0.
Okay.
Okay. So, I advise you to play with the questions on this chapter. The one for N3, hammer the questions on this dynamics. The one for N2, hammer the questions on dynamics. Please send me a WhatsApp if you get stuck on any question.
Okay. Cool. Will do.
Yeah. I'm looking at the time because I've got